In other words, we established a base there. So
what you were saying, by definition, if two viruses reacted, they belong to the same group, and if a virus reacted with viruses of two different groups, then they weren't two different groups.
They were not two different groups, but that was based on actual testing and retesting all along the line. But then when we began to test viruses belonging to the so-called minor groups, C, Guamba, California, and so on, we began to find that there were some not always reproducible, but appeared repeatedly that some viruses of a group, say Guamba, would occasionally react with viruses of another group, Bunyambuera or Group C. And that had to be worked out in a rather statistical fashion. In other words, take 10 viruses from 10 anti-sera from this group and 10 anti-sera from this and to the other, and see how often the cross reactions, which were minimal, all that by complement fixation test was done, and see how often the probability that there is a cross reaction occurs between, say, 5 of the established groups and 5 of the other groups. By doing that, we began to realize that there were a number of antigenic groups, I forget all of this now,
16
in the Bunyambuera supergroup that cross-reacted. There was between the California and the Group C and the Guamba and the Bunyambuera and all the other groups. There were minute reactions that could often be reproduced. That is, the same sets of reagents, that there was no problem about that. That could be reproduced, but taking, say, 5 different antibodies against Marituba, just to pick up a name, 1 or 2 of these might react with virus in the California group, but not the other 3. So that it was a question of weighing the evidence. Now, none of them ever reacted with Group A or with Group B or with that was what led me to suggest that perhaps there is a supergroup. In other words, defined as well as you can define by distant relationships which are not constantly observed as they are between viruses of a real group. And that led to the creation of that supergroup. Well, obviously, then
so you really didn't reverse your dictum. You bent it a little bit. You said they were
right. The
groups, but not really.
Not really. That's right. No, it was hedging. Yes, that's right. Because actually, at the time, we could have said well, there is no such thing as 16 groups. There is only one.
Right.
The Bunyambuera. Well. Being practical about things, and I think that one of the reasons why the complement fixation test can be used as a practical measure, if we had made the Bunyambuera supergroup a group on an equal footing with A and B, the whole thing would have been chaos again, because you would have never been able to put any virus that comes along into the Bunyambuera group, that is the supergroup, by serological test. It would have been a hit and miss proposition.
Yes.
Given a group A, I can always put it in group A, no matter how distant it is. It belongs there. And the same with group B. But if we consider the Bunyambuera group, formerly the so-called supergroup, then the grouping would have been really very haphazard. This way, we had it both ways. It is a supergroup in the sense that there is some distant relationships, but don't expect miracles. You cannot, if you want to group a virus, you have to go to the serotype, that is to the antigenic group within the larger group.
Well, we did this by preparing grouping fluids.
That's right. That's the way we did it, yeah.
With Bob and Loring Whitman and others?
Yes, that's right. Everybody at the laboratory during those days worked a great deal. Now, that is only, you might say, in some ways it has to do with taxonomy, because then the grouping fluids were done by putting together any viruses, not necessarily related. First, we had the related viruses, group A, group B. Then it became, there were viruses that didn't belong to any group. So, but still, we grouped 3 or 4 of them, put them to the same animal, and we knew that this serum will react against, say, Crimean hemorrhagic fever, against, I don't know, call it Naples sandfly fever, or 3 or 4 completely these similar things. It served the purpose of reducing the number of tests that you had to do. Instead of doing 5 tests to test 5 different viruses, 1 would do it. In addition to the fact that some of them, the grouping was a natural one, so to speak, because there was a relationship. I always prefer to use the related viruses, because by inoculating animals with 3 or 4 related viruses in a group, you really actually had reaction against the rest of them. You really don't have to put every group B in an animal that you inoculate to have an antibody that will react with all group B. If nothing else, by hemagglutination inhibition, you see. And also,
well, that's something we should get into, was the hemagglutination inhibition test.
Yeah.
Having separated the group A viruses, now known as the toga viruses, alpha toga viruses,
alpha viruses,
and the group B viruses, now known as the flaviviruses, and the viruses of the Bunyan-Weir supergroup, you have at least made a start in taxonomy and certainly in classification of the viruses.
The Rockefeller Foundation had decided to go into the study of all these tropical viruses, as they were named at the time. And it was about that time that Albert Sabin and Ed Buscher, had worked on the hemagglutination inhibition of some viruses, perhaps yellow fever, St. Louis encephalitis, and a few more, and had produced the hemagglutinins work. The hemagglutination inhibition was a test that had been established with arboviruses at that time. That was following, of course, the lead given by George Hurst with influenza. And talking about the future of the program, I know that Max Steiler said, well, why don't we use the hemagglutination inhibition test? We have the mouse neutralization, we have the complement fixation test, let's try another test, and with which I agreed entirely. So then we began to see how we could produce hemagglutinins and use them to establish or confirm or deny relationships among these viruses. We used as a source of material those days exclusively the newborn mouse brain, practical for the same reasons that was practical to use them for the complement fixation test, the purity of the material due to the low content on lipids, and increase in concentration of virus and therefore of antigen. We prepared them not just by separating, making a saline suspension, which is what Sabin did, but rather by going to the acetone, removing the inhibitors, and then we knew that the inhibitors being lipids or associated with lipids, that's the way it had to be done.
Was that serendipitous, or did you decide
I decided to do
that?
it. Since the antigens are better by CF, why not try them with this test? And in a way it was serendipitous, because there was no reason at the moment that we knew why it should work out. Subsequently we learned that it works better because there are the HI test is played by non-specific inhibitors, both in the sera that you test and in the material with which you prepare antigen. And these inhibitors was subsequently found were lipid in nature, so therefore by using the acetone we removed the lipids from the antigen, and subsequently we had the same thing we applied to the sera, treat the sera with acetone and you have no inhibitors. We used other methods because they were more practical than treat with acetone, say 100 sera. To use either the bentonitis we use first or kaolin was a much practical thing. But that's the way in which we began to use the hemagglutination inhibition. We applied it to sera. I remember one of the batches that came to us from Trinidad, the laboratory in Trinidad, which people had been bled. At the time they had an epidemic or an outbreak of yellow fever, not an epidemic, little outbreak. We tested sera. They were being tested by neutralization test locally, but we did test them by hemagglutination inhibition. And the astonishing thing was that most of the sera, 80% of them, reacted with extremely high titers against all the antigens with which we put them, yellow fever, ileus, St. Louis, and so on. It just made no sense. So we were alarmed and wondering what gives. I mean, this seems to be impossible. Well, we learned subsequently that those people had been exposed to dengue and perhaps other group B viruses during the course of their lifetime, and what we were picking up was a group reaction against the antigens of group B. That we determined experimentally by inoculating animals with one virus and then with a second one, and having reaction against all the viruses in the group. That was particularly clear with group A, in which the relationships are a little more distant than in group B. So we realized then that we had a magnificent tool for grouping viruses instead of having to struggle hard on occasion to do it by complement fixation test and miss cross-reactivities unless the viruses were close together. Through the use of the hemagglutination inhibition test, we might be able to do a much better job. And that we used to great advantage to establish the antigenic groups, because the titers were higher, the separation of groups was very sharp, and any virus in one group would react against the others.
It was 1958 when you and Delphine Clark published this.
We published that in 1958, that's right. We put all the procedures which had been published in two or three publications. In one of them, the first one describing the grouping and the antigenic relationship was done in association with a young woman, Lenora Brown, who helped me very much with it. And then we had several other procedures that were described, but at that time in 1958, Del Clark and I decided that the whole thing had to be put together in one compendium, one manual, and that was that publication, which is still pretty much referred to because it has the basis of all that we did. We described there the way of preparing the antigens, and the great contribution that Delphine had was to make a suspension in sucrose rather than the suspension in saline, which really stabilized the antigen considerably.
Now you had the complement fixation test, you had the baby mice, and armed with the hemagglutination test and the hemagglutination inhibition test, you were ready to begin to identify viruses from all the Rockefeller-found laboratories.
Oh yes, and other laboratories.
Far-flung as they were.
That's right. So then we were ready with a set of reagents or reactions that would group them, separate them, and establish more closer or distant relationships. I think at that time we had as much as we could do from the point of view of what you might call studying one of the phenotypes of the virus, not obviously the genotype, which is another matter. That is for a subsequent era of the development of the study of these agents. But at that time, and with those methods, I think we could do a lot. And we then routinely tested viruses or agents that came